they do that to Matt, we're all screwed.
Exactly. So I just said prepare to
All right. Okay, so I just sent an email with like the end of semester updates. So the first thing is the exam time. So for you guys, it's Tuesday at 11 a.m. Okay? Now I think technically the schedule says 10:30, but it's only an hour test, so like let's just keep it at 11 so that, you know, we're used to the time. So it's in here at 11 o'clock on Tuesday. Since you guys had the first exam, I kind of, I don't know, customized the schedule around that because I didn't want it to feel like so crammed in that your like practice tests are due. You know, you have to do those Monday night and get them before you do Tuesdays and stuff. So what we're going to do on Monday's class, basically we'll probably end early today and potentially on Friday as well because you guys are all a little bit ahead of my first class. So what we're doing is finishing the new material today, practicing it on Friday, and then on Monday, it's up to you guys if you want to come in or if you want to study, just use the time on your own. So it's not that I'm canceling class. I'll be here. The best use of the time, in my opinion, is come in, finish up the practice exams here. Then you can ask questions because I'll be here as you're working through them, just as they come up. But if you have, you know, a different schedule and you want to use the time to study at home or to study for a different class, that's fine with me too. Okay? So that's Monday's class. This is all in the email. I'm just reiterating it. And then the other annoying thing is that I felt like buffers was hard enough that I didn't want to include weak acid titrations, which is also kind of tricky. So we are going to do titrations for strong acid, strong base, but we're not going to do any weak acid ones. The problem was the homework, once people start it, I can't take problems off or it messes their assignment up. So the solution is you don't have to do any weak acid titrations on the homework. I just sent you the questions that could potentially be on the homework and the answers, okay, for the weak acid titrations. So if you run across one of those, just look at the PDF and like put the right answer in so that it doesn't, you know, keep asking you those questions until you get them right. Does that make sense? It's very much a nuisance, but that's the best way I could come up with doing it. Okay? All right, so the last topic that we want to cover is titrations. Again, strong acid, strong base only. And so we're going to talk through those today. Now, if I remember right, you guys did titration. I don't know if it was an acid-base one, but you did a titration in Chem 1 lab. That's been a while, though, so it's probably not super fresh. And I also don't think you guys did a ton of calculations along with that, okay? So we're going to recap what a titration is and kind of the different points, and then we're going to do calculations at different points during the titration. Okay, so the main idea of a titration is that you have some solution. In this example, it's an acid that has something unknown about it. So a lot of the times it's the concentration isn't known, or maybe even it's an unknown acid, like you don't know the identity of the acid, and so you don't know the equilibrium constant. But there's something unknown about it that you're trying to determine. And then in the burette is your known thing, in this case a base. So you know the concentration of it. And then you also are going to know the volume to a very precise degree because burettes are marked and calibrated very precisely. So you add a little bit at a time until you hit what we call either the end point or the equivalence point, and then you're able to identify exactly how much NaOH, in this case, that you added, and that's what's going to help you figure out information about that unknown, okay? The way we identify the equivalence point is by using an indicator. So indicators are something that change color when there's a change in pH. So if it's, below 7, let's say, in the case of a strong acid, strong base, then it'll be clear. And then when it's above 7, it'll be pink. So you dribble a little bit in, it stays clear. Maybe you hit a point where there's like a little bit of a flash of pink, but then as it stirs, it dissolves. And then you add like one more drop, and it turns pink completely. And that's the end of the titration. Now, what do we mean the end? We don't mean you can't add any more. That's not, this equivalence point is probably a better term than end point. It means that you've hit the exact ratio that you need for the reaction to be, if it wasn't a 1-to-1 ratio, we would just say the stoichiometric ratio. For acids and bases, that's 1-to-1. So for an acid base, it's when the moles of the acid are equal to the moles of the base. Oh, I guess I have that in the text, but whatever, we'll rewrite it. So you're gonna see that in the color change. If you're doing a strong acid, strong base, you'll also see that that's where the pH becomes neutral. Because as you're adding them together, once you hit the point where you have the exact same number of moles of acid and moles of base, you've now neutralized all of that acid and base, and you just basically have water and a salt. Okay, so you would also see that in the pH measurement. So a lot of the times we monitor these or do calculations that are the pH at given points throughout the titration. So you can think of this as like the progress of the titration. You're adding more and more and more of the base in this case, and then you're monitoring how the pH changes. So there's 4 different regions where we're gonna do calculations. The first one here is before we've added any of the base. So we're measuring the thing in the flask. We're just measuring the acid in that case. Then somewhere along here where we've added some NaOH, so it could be any region in there, but where we've added some NaOH, but not enough to get us where they're equal to the acid. Then we would have the equivalence point. Whereas if we're looking at pH, so for the equivalence point of a strong acid and strong base titration, which is the only type we're doing, the pH is equal to 7. So no calculation is necessary there. You could do it, but you're just going to find out that it's 7. But there is like, a lot of the times we'll calculate what volume is needed to get to that point rather than just calculating the pH itself. And then the last one is after we've passed the equivalence point. Okay, so those are the 4 types of calculations we're going to do with regards to titrations. Okay, maybe what I'll do too on Friday, we're gonna practice these 4 calculations today. We'll end early once we finish that. At least my first class didn't, but my second class did, which I assume you guys will. And then we'll have you guys practice these 4 types on Friday. And then I think I'll also pull in a buffer question, just because those are kind of the hardest ones of this chapter, I feel like. And so, doing another practice of that on Friday would be good. That brings up an important point. I was working on writing the test yesterday, and remember, usually they're pretty well divided, 10 questions on this chapter, 10 questions on that chapter. Because we've only had a couple sections in chapter 18, 17 is definitely dominant on the test, certainly 2/3, maybe even as much as 15 questions, 3/4 of the test is chapter 17. And then only a quarter or a third on 18. Okay, so just keep that in mind, that 18 is more difficult. We also didn't do as much in it, so it's not going to be as many questions on the exam. Okay? All right, so moving forward. I summarized kind of some key points about each of these types. So go ahead and label these both on the graph and on here so that you know, like, we're talking about these 4 different points during the titration. And it doesn't give you all of the steps here, but kind of the main thing it misses is a reminder to do the dilution. But it gives you kind of the guidelines for how to do each of these 4 steps. We're going to do them all together right now, but this might be useful when we're kind of doing more independent practice on Friday. All right, so let's go ahead and jump in. So this is the titration we're doing. We're going to use this volume and concentration of HNO3, that concentration of NaOH throughout all 4 of these questions. So it's one titration, different points during it. So this information is pertinent for the whole thing. Okay, so in the flask, we've got 25 mils of 0.22 molar HNO3. And then in the burette, we've got 0.13 molar of NaOH, and we're going to drip, drip, drip NaOH into it. The first question is before any NaOH is added, okay? So all you have here is the 0.22 molar HNO3. Now, remember that pH is not based on the number of moles. It's based on the concentration, the molarity, right? pH is the negative log of the H3O plus concentration or molarity. So I don't really care that I have 25 mils of it. If I know that the concentration is 0.22, that's all that really matters, okay? The other thing that's important is this is a strong acid. And how do we determine the pH of a strong acid? Well, all of that 0.22 molar is going to get converted to HNO3. H3O plus. All the HNO3 will get converted to H3O plus and NO3 minus. We don't care about the NO3 minus. Okay? It reacts with water all the way to products. So for the pH, all we have to do is take the negative log of 0.22. Okay? So go ahead and do that. Make sure you get the same number. So the pH you get should be we'll round it to 6.58. That's all you have to do because there's not any NaOH added. So that one's pretty straightforward. Okay. So second one, calculate the pH after the additions. This is the second point. Label these. Calculate the pH after the addition of 18 mils of NaOH. Okay, let's just jot down so that it's all on the same page. That was 0.13 NaOH, and this was being added to 25 mils of 0.22 molar HNO3. Okay. All right, so similar to when we did buffers, we're going to need to do a dilution step, because we're adding together 2 volumes, right? And if something's 0.22 molar, but then we add water to it, that changes the molarity, right? It's like if you had, a pint of water with a teaspoon of sugar, but then you add another pint of water, that changes the amount per liter, okay? It changes the amount, the molarity. So we're going to have to do a dilution. And then we're going to do a consumption step, just like we did with buffers. We don't have to do the equilibrium step, though, because these are strong acid, strong base. So I always like to write the equation before I do the dilution steps, because then I can just write it right under it. So I'm going to go ahead and do that. So HNO3 plus NaOH. And this isn't like super critical that you write the equation exactly like this. You just need to know, like if you wanted to, you could write these, you could write these as H plus OH minus makes water. Because that's the net ionic equation. It's the only stuff that matters. Or we could write it like this. It's probably how I prefer to write it. Or you could even write the NaNO3 as one compound. But don't stress about like, am I writing it correctly, as long as it's the acid plus the base. And in this case, we don't care about the products because it's just water and some ions. It's not really relevant. Okay, so we're going to do a dilution for each one of these. So M1V1 equals M2V2. So for HNO3, 25 mils of 0.22 molar for a total of, let's see, 25 and 18, 43 milliliters is our new volume. Because we're adding these volumes together, we're making a new solution that's, you know, bigger, more liquid in there. Okay, so I get 0.128 molar for the acid. And then for the base, it's going to be 18 mils times 0.13 molar over 43 mils. Or 0.054 molar. Now, this should make sense that the base is not as concentrated as the acid because we haven't hit the equivalence point yet. The equivalence point is where they would be equal to each other. At this point, there's less base because we just haven't added as much yet. Okay, so we're going to now do the consumption step. So these are our initial amounts. And now we're going to do the consumption step and the final. So we're going to subtract the smallest one. Okay, I want to emphasize that I'm saying the smallest. In this case, it's the base. When we get to after the equivalence point, the acid is actually going to be the smaller one. But, you know, you can't have negative concentrations either, so you always want to subtract the smaller one. So I don't think you'll forget that. So I'm going to take 0.0454 off of both of these. It's like the base is like eating up that amount of acid. They're reacting together, forming water, and then you're just going to have some of the acid left over. Specifically 0.074. And none of the base. All of the base gets used up, reacting with some of the acid, and you leave a little acid left over. I didn't write anything on the product side because I don't care about that. This doesn't have any effect on pH, so I'm just going to ignore it completely. Okay, now I have no base and I have a little bit of acid. How do I find the pH? It's a strong acid, so I just take the negative log of that because all of that HNO3 will produce H3O plus. Okay, so first one, straight acid, we just take the negative log. Second one, we dilute it, we consume all of that base that we can, and then we take the negative log of whatever of the acid is left over. All right, next one, at the equivalence point, what's the pH? Don't have to think at all. It's a strong acid and a strong base. They just neutralized each other. They reacted exactly. We could calculate what it is. It would end up coming out to be the same number of moles of each of them, or the same molarity rather. Like if we went through all of these steps, like let's say you forgot how to do this and you went through all these steps, what you would find is that these two numbers would be the same, and then you would get 0 of both, and then you're saying, oh, there's not an acid or a base, it's just neutral. But save yourself the time. Just know that it's 7. Okay, the other part of the question, though, calculate the volume needed to reach the equivalence point. So they're like, let's pretend we don't know how much it's going to take to get to 7. Let's calculate that out. The key point there is that the moles of the acid are equal to the moles of the base. And we know we started with 25 mils of the acid and 0.22 molar of it, right? So think about, how do I get moles from volume and molarity? I multiply them, right? I multiply, if I would put it in liters, and then I would multiply the liters times the molarity, and that would give me moles. So this looks really similar to the dilution equation. We're going to have molarity times volume, but instead of 1 and 2, because we're not changing the volume, we're just going to put molarity of the acid times the volume of the acid equals molarity of the base times the volume of the base. It's not a coincidence really, but it's just a different application of how you get to moles. So we know that moles acid equal moles base at the equivalence point, and if you multiply volume times molarity, you get moles. So we're just substituting in and saying that's how we would get the moles of acid. That's how we would get the moles of base. So we're going to solve for that volume of base that we need to get to the equivalence point. So the original molarity of the acid was 0.22 molar. The volume of the acid was 25 mils. And the molarity of the base was 0.13 molar. Okay, so solve for the volume, the mils of the base that we need to add. Okay, so what it's saying is that we're gonna drip, drip, drip the NaOH in, and when we get to 42.3, that's exactly where moles of acid equal moles of base. One more tiny little half a drop, that would change the color to pink, and then we would know that we were at that equivalence point. And I don't know, if we were measuring the pH, we would see it at 7 as well. Okay, last type. Then I think I actually have a buffer problem we could do from earlier. All right, last type, pH after we've added 50 mils of NaOH. So we're going to do the same thing as step 2. We're still adding the HNO3 to the NaOH, making water and sodium nitrate. And let's just see what happens when we do the dilution, because we should have excess NaOH. We should have more of that than we do of the nitric acid. So I'm going to write those numbers down again, or you can scroll back. Okay, so I'm going to do the dilution, 25.22, and now it's a total of 75 mils. Okay, so let's just look back at number 2. So in this one, we had quite a bit of acid, only a little bit of base. So we used up all the base and saw how much acid was left over. Here, we've got less acid, more base. So now we're going to use up all the acid and see how much base is left over. You always have to subtract the smallest one because you can't have a negative molarity. Let's see. What is that? 714. Okay, so 0.14 molar NaOH, that's the same thing as the concentration of the OH minus. So to find pH of a strong base, you just take the negative log of the OH minus, or 0.14, and that gives you the POH. And then you do 14 minus the POH to get the pH. Wait, did I do something wrong? That's a different number.
0.014.
Yes, okay. I was like, that's not the right number. Thank you. Okay. There we go. Okay, so 12.15. So let's kind of look at these numbers now and go back to that chart. So we had 0.6 before any NaOH was added, then 1.13, so we don't know how much, how far along that curve we are, then 7, then 12. So if we look at that curve, it looks pretty similar. Now, this is a generic one. We don't know what the concentrations were, but 0.6 was around here, 1 point something was around here, then we went up to 7, then we went up to 12. Okay, so that's why the curve has that shape. You have this dramatic rise right around the equivalence point. At this point, you've consumed all of the base and have some acid left over. Up here, you've consumed all the acid and have some base left over. Okay, so those are the only types of titration calculations we're going to do. So concept, and then those 4 types of titration or of calculations. Let's go back and do, I'm pretty sure there's a buffer one we skipped over. Yeah, let's do this one. And then we'll see, maybe I can make one up using this. So I'm not going to give a whole lot of direction. We have the time. Just go back and look, where you might be able to find this. They're saying the ratio of the base to the acid, they mean like CH3, NH2 over, other way around. Nope, hold on. No, that's right. This is the A minus over CH3, NH3Cl. This is the HA. Okay. So they're talking about that ratio. Like, is it 2 to 1? Is it 1 to 1? Is it 0.6 to 1? And I'll give you a hint or something in another minute. So this is the equation you're going to always want to think of when you're thinking of buffers. Henderson-Hasselbalch equation. So another important point, they give you the KB, so you need to convert that into KA using this relationship. And then last part of this that might present a little bit of a challenge is remembering how to undo logs. So first of all, I did the pKa, and then I subtracted on this side, so 10.24 minus this value, so negative 0.402 equals the log of that ratio. They want to know that ratio though, so you don't divide anything when you have logs. The way you undo a log is raise both sides to the power of 10. So I'm going to do 10 raised to negative 4.02 and 10 raised to that log. This will cancel on that side to give me the ratio. And then I gotta double check that number. Doesn't look familiar. And then the ratio ends up being 10 raised to the negative 4.02 or 0.396. So meaning it's 0.396 A minus for every 1 HA. That's the ratio between the two. Anybody else get that? Did I do anything wrong there? I can go back and double check, but. So just like a weird, different application of buffers, you know, we always start with kind of the most direct type of problem. But there's always different ways that you might use the equation. Most of the ones we did before, you were finding the pH. Okay, let's now, no, I think that's pushing it. I was going to say, let's do another one where we add like an acid to this or something. We'll do another one of those on Friday, just as a kind of good buffer practice. Okay, we'll stop there. Yes.
If I have an interview tomorrow for a job to get patient care hours for start getting stuff for PA
Good.
school. Can I give your name as one of my references? She needs 3 and I need 1 more.
Sure.
Okay,
Yeah.
is that okay?
Yeah.
Okay, I just want to make
Good
sure.
luck.
Thank you so much.
Yep.